right here. You don't have to see me for another, what, 7 days? Okay. This topic that I want to cover today is most fun topic, so to speak, but it's very less understood by a lot of people. Okay? I'd like you to flip your pages forward to section 8. Section 8 is demand. The voltage drop is the topic that I want to cover for the next 1 hour. What I'd like you to do is highlight the heading on 8-102. The heading says voltage drop. Along with it, it will say the word appendix D. You're going to go ahead and highlight that as well. Okay? On top of appendix D, you're going to write down the word table D3, comma, table D4. Go ahead and write it down on your code book. Now, what do we need? We need to understand from the pole to this receptacle, if the pole gives 120 volts, by the time it gets to the receptacle, how much drop is allowed? Okay? Or from the panel to this receptacle, how much is allowed? Do you guys see 5% and 3% numbers in 8-102? 5% is allowed, is the voltage drop allowed from pole to point of utilization, which should be my receptacle. Then you see 3%. 3% is allowed from the panel to receptacle. Okay? That's the maximum drop allowed. What that really means is 120 volts is given by the pole. The maximum drop that I can see is 5% of 120, which is 6 volts. So the lowest this receptacle should give my equipment will be 114 volts. Are we clear? That's called voltage drop. Okay? How do we calculate voltage drop? What's allowed, what's not allowed is based on the first table called table D3. So I'd like you to put one sticky on section 8 and then go to table D3. As the name says, table D3 means it's an appendix D. So go to appendix D, look for the word table D3 or the table with number D3. Table D3. Now page 526, I'd like each one of you to go to page 526 of your code book. Okay, let's get familiar with what this table is all about. I'd like you to highlight on this table, you're going to highlight 120 volts and 1%, these two numbers on this table. Go ahead and highlight that. Now, let's get familiar with this table. The first column that you see, okay, talks about ampacity of conductors. So let's say in my home I'm working with 100 amps. So I will go to 100 amp here, okay. Let's say I'm using a conductor of size number 6. So I will go to 100 amp, keep going to number 6. For 100 amp, the allowed distance for number 6 is what? 6.2 meters. So from the pole to my receptacle, the maximum drop allowed is 5%. But this table is based on 1%. So if in my installation, I was assuming that I'm going to go ahead with 1% drop, I will be allowed 6.2 meters length of conductor. Are we clear? But I know that 5%, up to 5% is allowed. How do we incorporate all those changes? We'll catch up in a bit. Okay? So Satinder, if I had number 10 conductor here and 10 amp service, how how much length of conductor is allowed. Number 10 and 10 amps.
50.5.
So 10 amps, you will go to a row of 10 amps and a column of number 10, I get 15.5 meters. Good job. Jaswinder, if I had 40 amp service and number 4.
40 on number 4 is
15.68. Okay. I would also recommend you guys to use a straight pen or something such that you can get to the right number in your exam. Next question is for William. William, if I had a 200 amp service and 4 aught. 15.8 meters. Varinder, if I had a 50 amp service number 3
number 3
and 50 amps, 50.
15.7.
Perfect. Do you guys understand the table now? Okay. If you go to next page, there is some math done on this page as well for you. Go ahead and highlight that. There are 2 examples that has been done for you to explain how would you find voltage drop or how much distance is allowed in a situation where I have more than 1% drop. Okay, go ahead and highlight these for me. And right underneath here, the space that's left, you're gonna copy stuff that I'm gonna write on the board. Okay, so write down L is equal to LT times P times DCF times voltage over 120. Just copy this formula down. Okay, what does L represent? Final length of your conductor. And length is given in meters. LT is length given in table D3. Okay? P stands for percentage drop. And that's measured in percent. DCF stands for distance correction factor. How do you calculate DCF? I'm gonna do, let's assume, once you have done copied up to this point, and I'd like you to stop such that I can explain you how to calculate DCF. The last one I'm gonna write down before. V stands for voltage. If I'm working with 120 volts, 240 volts, 600 volts, whatever that is, V is just voltage. This 120 is just a multiplier, has nothing to do with 120 volts. Okay, it's just a multiplier here. Now let's understand how to calculate DCF. Okay, DCF is given by a ratio of 2 numbers. First thing you're going to do is find out the loading factor. What does loading factor mean? Let's say I have a conductor that I'm using for 25 amps, okay? But it has a capacity to carry up to 50 amps. What's my loading factor? 50%. Yes or no? So 50%, once I find that number, I will come to page 527 of my book. If you see this table, you're going to go ahead and highlight the heading that says distance correction factor. Distance correction factor right here. Go ahead and highlight it. So once I have found the loading factor, okay, loading factor is a ratio of current conductor is being used for divided by total capacity of this conductor. Based on table 2. That's called loading factor. So right now, as I gave you an example, I might be using this conductor for 25 amps and the capacity is to carry 50 amps. So loading factor will be 50%. Once I figure this out, I will go to page 527, which is my DCF table. Okay. Then look for 50% column, which is right here. Okay. And if I am using a 90-degree zero, my number will be 1.06. That is my DCF. Okay. Are we clear? Once you go to this, look for that same percentage of the column and 90-degree zero if your conductor is 90 and find your answer. For now, just copy this information. We will practice few questions. You guys will be rocking after that. Total capacity of this conductor based on table 2 means current carrying capacity. Let's see. So I'm going to go ahead and practice one question. Please don't copy because the booklets you got, okay, comes with a step-by-step solution of each and every question. So you don't have to copy anything. I'm going to do question 4. Your solution is given right here on question 4. Okay? Don't copy, you don't need to copy, pay attention, it's very important to understand the concept. Okay? And I want Satinder to help me do this question. Is that okay? Yeah? Satinder, tell me dear, what is my percentage drop given in question 4 on section 8 classwork, page 52?
2%.
Percentage drop is?
2%.
2%. What voltage am I working with?
24 amps to 40 volts.
Okay, so current is 24 amps, voltage is
240.
240 volts, good job. What else is given to me? I am given conductor size. My gauge wire size given is
10.
number 10. Okay, that's it. Now I need to find out how much distance my conductor is allowed to go, such that I only have 2% drop. Now for me to find this, the first step, Satinder, I'd like you to do it is go to table D3. Okay. On that table, do you have a 24 amp row? So 24 amp row does not exist. So you're going to pick up 25 amp row, equal or bigger. Okay. And number 10 column. What do you see is the distance? 6.2 meters. Perfect. This length, guys, become length from the table called LT. Okay. So now, if I had to use this formula to do my math, okay, how would I do it? I will plug the values of whatever I know. So far, I know that LT here is 6.2 meters, okay? Then the value of percentage drop given is what? 2%. Now DCF, I don't know. Voltage, I do know, it's 240 volts, right? So the only thing left for me to find out is the DCF. How do I do it? As I said, the first thing you gotta do is find your loading factor. Now, right now I'm using this conductor for what? 24 amps, isn't it? Based on table 2, Satinder, you're going to go to table 2, look for 90-degree C column, and tell me what is number 10 good for. How much current it can carry. Table 2, not D2, but 2. Not in appendix D, it's table 2, like table 1, 2, 3. Okay? So go to table 2, look for 90 degree C column and find my answer for number 10.
40.
40?
Yes.
So now pick up your calculator and divide 24 and 40 to find my loading factor.
0.6.
0.6. So my loading factor becomes 60%. Okay? Now you're going to go to distance correction factor table, page 527 of your code book. Okay? You're going to go to 60% column and 90 degree C row. What is my DCF?
1.04.
1.04.
04.
So take this number and plug this value right here. Okay?
It's 90 degree.
Because it says the conductor is rated at 90.
Yeah, it's 1.02.
1.02 or 1.04?
04.
1.04. See that again here. L is equal to LT. Length from the table is 6.2. Next is percentage drop, which is 2%. I am given DCF that I just calculated for 1.04. Voltage I am working with is 240 divided by 120. If I get rid of these, what do I get? 2. So Satinder, you're going to multiply 6.2 with 2 with 1.04 and a 2 again, dear. What do you get? Your total distance will be what?
25.79.
25.79, so 25.8 meters and we are done. Is it too complicated? This is the right way of doing it. Now I'm going to teach you a wrong way of doing it. What's that? The easy way. Okay? But do you understand the right way? Okay, I'm going to repeat what I had shown. I was already given 24 amps and number 10. So what did I do first? I went to 24 amp row did not exist. So I went to 25 amp row and number 10 column. My answer came out to be 6.2 meters. That became length for from the table. Okay. I was already given percentage drop of 2%. I was not given DCF that I gotta calculate. Voltage is 240. In my opinion, most of people really don't know how to do all of this. Because this comes with a lot of practice to calculate your DCF, actually this part. Okay, DCF is a little harder to calculate, but how do you calculate that? You will find loading factor. You're using the conductor for 24 amps. You can go up to 40 amps because that's the capacity of this conductor. You found your loading factor is 60%. Based on 60% and 90 degree zero, you found your answer being 1.04. From your exam standpoint, it's not the wrong method, but another technique you could use is just use DCF being 1. You don't have to do the whole math. Just do multiply all the numbers. So 6.2 times 2, just assume DCF being 1, 240 divided by 120. Now I would like Jaswinder to multiply all the numbers and give me my answer here. He's already on the game. Go ahead and do it. 6.2
Multiplied
times 2 times 2. So 6.2, I think I could do this in my head. 24.8 meters is my answer. Do you guys see that? So out of ABCD choices in your exam, your choices usually are quite far apart. Your first choice would be 20 meters, 25 meters, 30 meters, or 35 meters. Or it might look like 22.1 meter, 25.8 meter, 30.2 meter, and 35.7 meter, for example. Okay? Even if you tried to not calculate your DCF, your answer came out to be about 25. Your real answer is 25.8. You will still be able to figure out that this could be your closest match. Because DCF is 1.04, 1.08, 1.0 something. So even if you use 1, you will still be able to get this question straight in your exam. So that's the technique you can use to bypass that step of DCF. But again, my job is to teach you the right method. So, do you guys want to practice another question? Okay, I'll give you guys a couple minutes and a question to do. On the same list, I'd like you to try question 7. Try doing question 7 and we'll check our work in 5 minutes. This question for you guys and see if you did this question okay or not. William, are you going to help me do this question here?
Yeah.
Okay. Tell me what is the gauge wire size given here?
Number 8.
Number 8. What's the ampacity given?
27 amp.
27 amp. Am I given voltage?
Yeah, 120.
120. And percentage drop allowed is?
3%.
2%? 3%. Okay. Now, William, the formula that I taught you is what?
L equals LT by P by DCF by 1.
5 voltage divided by 120. Now, tell me, William, the first step that I'm going to do is go to table D3. Okay. You're going to go to 27 amp probe. Do you have a 27 amp probe?
No.
No. So the closest one is what?
32.
32 amp probe. And what will be the column? Number 8 column, eh? Number 8 is the conductor size given. What is the distance given?
7.7.
7.7. Good job. That becomes my LT, length from the table. Now, the last step left is find DCF. How would we find DCF? I'm using number 8 conductor for 27 amps, but based on table 2, what is the capacity of number 8? 55 amps. So you divide both numbers for me. What is 27 divided by 55?
0.49.
0.549?
0.49.
449. Or 49?
49.
49. So 49 means 49%. I'm going to go to equal or higher. So I'm going to use 50% column on page 527, the distance correction factor table. Okay? So 50% column and 90 0. What do I see for my DCF? DCF is 1.06. You guys are on track. See, you don't have to use DCF as 1 anymore. You know it all. Okay, so let's use this formula to find our final answer. L is equal to LT. So length from the table that we just calculated here is 7.7. So L is equal to 7.7 times percentage drop is 3%. DCF that we just calculated, 1.06, voltage is 120 divided by 120. Get rid of these. What do I get when I multiply all these three numbers? What is my final length?
24.48.
24.48. which is in meters. You guys rock. How clear is this concept? Scale of 1 to 10. How clear is the concept? 10. William? 9.5 or 9.999. Marinder? Is it clear or not clear at all here? It's clear. Anything I can help you to understand the concept of voltage drop? Satinder, is it super clear?
It's okay.
It's okay? So I'm going to repeat the steps you have to do. Anything when you do voltage drop calculation, okay? First thing you do is find out length from the table. How do you do that? Whatever ampacity is given to you, you will go to that number or a number higher in table D3 for that gauge wire size to find your length from that table. Then the next step left is finding out DCF. This DCF is given by a ratio of what I'm using this conductor for, which is 27 amps, and what I can use it for based on table 2, which is 55 amps. My loading factor is about 49%. I can't have a column of 49%. Either it's 40 or 50. So I will go equal or higher. Okay? The higher number is 50% based on 50% column and 90 degree zero. My answer comes out to be 1.06, which is my DCF. Then I plug the values in. My answer comes out to be 24.48 meters. Any questions on voltage drop?
We mostly use the higher,
Always equal or higher.
not lower.
Why? Or you're just trusting whatever my teacher says I'm going to believe. Where in your code book it says that?
Because I calculate first 25 and the
answer didn't come out to be right.
Yes.
So where in your code book, never blindly trust your teacher either. Where in your code book, because that's your Bible, trust your Bible. What does your Bible say? Use equal or higher. Where does it say? So let's go figure that out. You're gonna go to table D3,
Can you please tell me that 55 ampere table?
table 2. Okay? So you guys are gonna go to table D3, back to where we were. Okay? You're gonna come to page 527. Okay? Right above distance correction factor table, the last line, where calculation and ampacities fall between two columns, the factor in the higher percentage column is used. Do you guys see this? Last line, note 3. So go ahead and highlight that. Page 527, note 3, right here, the last line. That if your number is between 27 amps and then you use not a 25 amp row but 32 amp row. Same thing, if your loading factor is between 50 and 60%, what am I going to use? 60%, the higher one. Okay, if the loading factor was between 70 and 80%, what would I choose? The 80% column. Always equal or higher. Are we clear?
Yes.
Any questions on voltage drop? Now, this pretty much concludes the topic that I wanted to discuss on voltage drop.
We definitely get one of those questions in the exam.
Absolutely. Absolutely.
Is it same like low voltage?
This is low. I'd like each one of you for us to understand what voltage we are working with. When we did not have google.ca, what did we really still have 20 years ago? Codebook. And codebook has something called definitions. So you're going to go to section 0 for me, guys, and look for alphabet V for voltage. Check it out. We do not work with high voltage. And the guys that come and fix our cable in our house, when he comes, walks in and says, oh, I'm a low voltage guy. It's wrong information. He's not a low voltage guy. We are low voltage guys. Where does it say in our code book? Look for the alphabet V for voltage. What page is it on?
11.
Page 11?
Yep.
Let's go check that out. Page 11. Extra low voltage is between 0 and 30 volts. Do you guys see that? Okay. What is low voltage? From 31 up to 750. Every electrician only works up to 122.40, but practically speaking, up to 750 we are allowed. Okay? What is extra high voltage? Extra high voltage or high voltage, what does that really mean? Any voltage beyond 750 volts is high voltage. Okay? So to answer your question, dear, we are not done because I still haven't taught you table D4. Okay? What we covered in the previous topic is how to calculate voltage drop in case of 120 volt circuit. Well, what if I'm working with 24 volt circuit, which is called extra low voltage? How do I find voltage drop in that case? I will follow table D4. So please go ahead, go to table D4, which will be on page 528 of your code book, and let's get familiar with the table D4. Table 2. Table 2. What is the difference between table D3 and table D4? It's still a voltage drop table, but we calculate for an extra low voltage circuit called ELV. So let's check it out what this table is all about. Now the easy thing to do, guys, is on page 528 your formula is given to you. So go ahead and highlight the formula you're going to use. L is equal to V over 6 P over 5 IT over I times LT. I want you to pay a bit more attention. Under table D4, do you see 46-306 sub rule 1? Do you guys see this?
Yeah.
This voltage drop calculation does not belong to section 8. Why? Then go one page before this on table D3. What do you see? You see 4-004. What is the difference between section 4 and section 46? Section 4 is only for power conductors. What is section 46? Go check out and tell me what section is 46 and what does it do. What is the heading of section 46? Go to the beginning of your code book, look for 46 and find out the name of that section. For emergency power. Emergency power is up to 30 volts. So anything to do with extra low voltage drop calculation, your answers are not on table D3, it's on D4. What's on D3? A 120 volt circuit, 240, 600, anything up to 30 volts, you're going to come to table D4 to find your answer. Are we clear? We are going to understand this table, which is much simpler than D3. I'm going to go ahead and pick a question. Don't copy it, your solutions are given in your binder. The only thing you gotta do is pay attention. So for now, I'm just gonna use question 12 or try doing question 12 on the board, which is on section 8 classwork, page 53. Okay? I am given percentage drop is 7%. Okay? Gauge wire size given is number 12. Current I'm working with is 14 amps. Voltage is 12 volts. So the formula that I have to use to find my final length based on table D4 is L is equal to V over 6, I think T over 5. IT over I times LT, is that correct, guys?
Yes.
Okay, let's do this together. Now, I'm going to ask David to do this question with me, dear. Is that okay? David, you're going to go to table D4, okay? Do you have a row of 14 amps?
No.
If 14 amps is not available, which one is your closest number?
15.
What is lesser than 14?
12.
12. So closest number is what you need to pick. Basic difference between table D3 and table D4. In D4 you pick the closest number. Where does it say in your book? Go to D4. Look for the first definition of IT. Do you see here? IT says current shown in table D4 closest. Circle the word closest. Not equal or higher, but closest. Means if I was given 14 amps here, of course I'm going to go to 15 amp row. But what if I was given 13 amps? I'm going to go to 12 amp row. Are we clear? That only happens in D4, not on D3. On D3 we always go equal or higher. Okay? So now, David, you're going to stay with me on this question, dear.
Yep.
Now go to 15 amp row. On table D4, you will go to 15 amp row. Do you have a column of number 12?
Yeah.
Okay. What is my value from LT?
1.9.
1.9 meters. Good job. What is current in the table that I'm using? Current in the table I'm using.
14 amps.
14 amps or 15 amps?
Or 15 amps, sorry.
The table only have 15 amps, so I'm going to use current from the table being 15. What is the real current the circuit is working with?
14.
14. What is the percentage drop allowed given? 7%. And voltage I'm working with is 12. So pretty much I have everything to put it in this equation to find my answer. Okay? So L is equal to V for voltage given to be 12. So I'm going to say 12 over 6 times P for percentage drop, which is 7%, divided by 5. Current from the table is 15 amps. I will divide by 14 because I is 14. Length from the table that we figured out is 1.9. So how do you do a math with bunch of numbers? Make your life easy. Multiply all the top numbers. Give me my one answer first. So David, go ahead and multiply 12, 7, 15 and 1.9. Give me one answer.
2,394.
And multiply the bottom number. 6 times 5 is 30. 30 times 14, 420 I think.
Yep.
Now if you divide both numbers here, what do you get? It should be 5 point something.
5.7
5.7 meters.
meters.
And you're done. How is it? Is it easy or hard? This is easier than table D3. You know why? Because there is no DCF. Isn't it? Do you guys need to copy? No, because the solution is given. What I'm going to do is give you one last question to practice on table D4. Okay, and give you a couple minutes to try doing it. If you do them well, or do that question well, I believe the voltage drop topic that I personally think you should be clear in understanding. At least I'll be convinced that you are clear. Okay? So in your notes, go to section 8 homework. Let's find a question that you can work with. So code review 2 is where that question lies. Code review 2, section 6. I'll give you guys 5 minutes. It's in the end. Code review 2 is after section 8 homework. Jasminder, are you going to help me do this question here? that question is? You know, when I teach a class in Alberta, I asked a question, I'm like, what have you heard about the class? They're like, don't sit, stand, because it's a big class there. Never sit in the front, she asks too many questions. So please tell me how to do this question here. Question 6 on Code Review 2, page 64. Tell me, what is the percentage drop given here? 6%? Okay. What voltage am I working with? 12 volts. And current I'm working with? 5 amps. Okay. So let's find length from the table here. Okay. Do you have a row of 5 amps? No. So you're going to go to a row of close to 5 will be what? 4 and a quarter. Okay. You will go to a row of 4 and a quarter and column of? What is the conductor size given? Number 6. Okay. So what is the length from the table? 26.7 meters. Good job. Now, current from the table that I'm using is 4 and a quarter. I can write down at 4.25 amps. Do you guys agree? Okay. Now the formula that I'm using is L is equal to LT, or is it V over 6, P over 5, IT over I times LT, is that correct? Sure, if you say so, you're my teacher, I'm tired anyways. So tell me, what is the value of voltage given? 12, we'll divide that by 6. Percentage drop is 6, I'll divide that by 5. Current from the table is 4 and a quarter divided by I. I'm working with 5 amps, and length from the table is 26.7. What you could do is multiply all the top numbers and find one answer and divide by all these numbers on the bottom. So multiply all the top numbers, what did you get? 81
70.
70 divided by 0.2?
Yes.
Divided by, dear, 6 times 5, 30, 150? Is that correct?
Yes.
Okay. When you divide both numbers, what do you get, dear?
54.46.
54.46, so let's name it as 54.5 liters. How many of you got it straight? Good, good, not bad. What's going on? You didn't get it. Okay. Are you clear on the concept of voltage drop? When do we use table D3? When we are working with 120 volts or 240 volts or 600 volts. When do we use table D4? When we work with extra low voltage. 12 volt circuit, 6 volt circuit, 24 volt circuit, up to 30 volts. Are we clear? Okay. What do we do in table D3? To find the DCF, we find the loading factor. How do we find the loading factor? Ampacity that I'm working with divided by the capacity of this conductor based on table 2. Once I know that information, I will go to DCF table and find my distance correction factor. In table D4, there is no need. The only difference between D3 and D4, in D3 we go equal or higher in ampacity. Okay? In case of D4, we go to closest for ampacity. Any questions on any of these two tables? So this pretty much concludes voltage drop calculation for at least for this class.